All right, let's see what we can do with this. What am I supposed to do with that 1? I mean, it says factor over the reals only. 1 is a 0. Synthetic division. That's a good idea. Okay, so we got a 1, 1, -1, 6, -6, -27, and 27. Good thing we didn't have any missing zeros there. Okay, so now we carry down the 1. Multiply. What do you get? Add. 0. Multiply. Add. Multiply. Add. Multiply. Add. Whew, this is wearing me out. Multiply. Add. Okay. Got a remainder of 0. That's good news. What's this thing at the end? Stay with me. We already got the remainder. That's 0. Constant. So far, folks, we have y equals. What is the factor that comes from a 0 of 1? X minus 1, right. We got an x minus 1. All right. And inside here, we have a constant of -27. What's after the constant moving from right to left? The linear term, which is non-existent because it's a 0. Then we have what? The quadratic term. Then we have what? A non-existent cubic term, thank you very much. And then last, but not a quartic term. We can keep factoring that, can't we? And we shall. Okay. That's a hidden quadratic. Break it up. Ooh, nice. X squared plus 9 and a minus 3. Right? Plus 9 and a minus 3. Because that's the only way I'd get positive 6x squared. Now, there is one more thing you can do. And you will do. All right. So we got our x minus 1. There will be 4 factors, a total of 4 factors. You need to decide which one of those quadratics down there factors, and what does it factor into? Show me the money. No lies. No, I remember you said we're stopping with all these.
Oh my God.
So something in there is irreducible. Look at your notes from yesterday. Maybe you'll find something that might help you. Okay. That is not true. Okay, because I know what you're trying to break apart, and I'll show everybody why that doesn't work. This is the one that has to be broken up. How we doing over here? Did you guys get it already? Okay, so I got this one, this one, this one, and one more. There should be 4 factors total.
You explain like why this one is broken. I mean, this one gets broken up, but not this one.
Okay,
I know you did it like yesterday.
like a difference of perfect squares. If I take x squared minus 4, I can break that up into x plus 2 and x minus 2. Okay, it's the insides and the outsides that are going to cancel each other out. It's because this thing is a negative that works. If it's a positive, okay, the problem becomes to get rid of that Remember, you have to have conjugates. The insides and outsides have to cancel each other out. And we need the lasts to give me negative 4i squared, which is none other than positive 4. So it would work if we were allowed to go all the way to the imaginaries. But they specifically said factor only over the reals. Real coefficients only. So they told me to stop. So they didn't let me go this far.
Who's telling you these things?
The instructions to the question.
So wait, why couldn't you just clamp the chop?
Right there.
So explain to me why you can't just do like
Okay, I know what you're getting at, so let me show you. So when you do this, you get x squared equals 2x, and 4. You get x squared plus 4x plus 4. Now, this term isn't there. That's why this factorization doesn't go with it. You need them to cancel each other out, which is why one has to be positive and one has to be negative. But you're not alone. There's going to be other people in this room that are going to ask the same question. Trust me. Okay, which one of those factors, which one of those quadratic factors was irreducible? Which one of these quadratic factors was irreducible? X squared plus 9 was irreducible. Now, I've had several people ask me, well, why can't you do x plus 3 and x plus 3? Okay, now, when you multiply those together, what happens in the middle? You've got a linear term of 6x, but it is clearly not inside the factor x squared plus 9. So, this is not true. Now, what did you do with the x squared minus 3? Yes, Miss Hensley? And there you go. Those are your 4 factors for this question. You might as well bank on one of these questions being on the next test, okay? I mean, seriously. You were given a 0. You had to use synthetic division. You had to factor it. Yes, quick question. If you're allowed to go to the complex numbers, you can, because if you allow me to go to the complex numbers, then I could factor this into x plus 3i and x minus 3i. But they specifically said at the beginning of this question, which is probably going to look really weird when I scroll down here, factor over reals only. So they forced me to stop. What? The people that wrote the instructions, which I guess would be me. Don't worry about it. They're just trying to make me look bad.
so what's the final 4 factors?
The final, so yes, March Madness, the final 4. Right here we go, is your final answer to the question. Now, does it matter in what order you write those factors? No, as long as you have them. And don't, make sure y equals is in there. Come on, it's got to be a function for crying out loud. Just because you feel like dropping the y equals doesn't mean you should. Okay. And with a wave of the hand. All right. Moving back to some notes on 2.6. We're doing a lot more with the rational functions, folks. And so we've already done some stuff with this. Looked at vertical asymptotes and horizontal asymptotes, domains, ranges, discontinuities, limits. Oh, it's all coming back. I know. You wanted another shot to redeem yourselves. Well, you'll get it. 'Cause you wanted it. Find the domain of this function and use limits to describe its behavior at values of x not in its domain. This is based on one of the regular parent functions, right? One of the 9 parent functions we worked with a lot. So 1 over x minus 2. This should give you some helpful information. Hopefully you know what the basic parent function y equals 1 over x looks like. Do we know what that looks like? Please tell me yes. Okay. Which quadrants is it in? I have no idea. Which quadrants is it in? Y equals 1 over x. That's a positive k value, so I don't think so. What do we think? It is, yes. We definitely have a branch that's up here in quadrant 1 and 3. Right. Are you attempting to do this? Yes, that is what we're talking about. Y equals 1 over x. All right. So that's the basic idea, you know, quadrants 1 and 3. What's going on with this one? It's in fireproof form. That's nice. Yeah, what's going on with that thing? Come on, you don't need a calculator for this. You just need to think. What is that x minus 2 doing in the denominator? Moving it which way? Moving it to the right 2 units. So, what's over here at x equals 2? Ah, yes, the vertical asymptote, x equals 2. Remember, the factors from the denominator, which are not removable, create the vertical asymptotes. Oh, don't. Take it back. Take it back. Don't say that. All right, now. I reminded you and taught you that in order to find the horizontal asymptote, you needed to take the largest power of x in the top and the largest power of x in the bottom. You needed to take the limit as x approaches infinity of that fraction. If you can reduce it, fantastic. If you can't, then take the limit of it. Now, technically, we would need to do both the left and the right. We would have to do limit as x goes to negative infinity. But for the functions that I'm going to choose for you, it's okay if we just do one of them. In reality, you would have to do both. But for the ones we're dealing with, one side will be good enough. All right? So what happens to that as x gets bigger and bigger and bigger and bigger? 1,000, 1,000,000, 1,000,000,000, 1,000,000,000,000. Is what? Is it positive? Is 1 over 1,000, 1 over 1,000,000, 1 over 1,000,000,000, are those all positive numbers? Yes. But it's getting closer to what? 0. Remind me, is a limit an x value or a y value? It's a y value. So the y value is getting closer and closer to 0. What did we just find? The horizontal asymptote. He said it wasn't. Okay, now, we need to figure out where the branches are. I suggest right now that you plug in 3 and 1. Those numbers would be helpful to you. In this particular case, I'm more interested in positives and negatives. Oh, yeah, sure. Yeah. Staring at the back of his eyeballs. I mean, eyelids. So let's see here. If I plug in a 3, what kind of number do I get? 1 over 3 minus 2. 1, is that a positive number or negative number? It's a positive number. In fact, it's 1. So we've got a point up here, which means, folks, this branch is up here. Plug in 1. Tell me what you get. 1 over 1 minus 2. You get negative 1. So that's down here, which tells me that we're dealing with this. So we tested 2 points, and we were able to figure out what the shape was. We didn't need a calculator. We got our brains. All right. Domain. What about the domain here? Remember, negative infinity is here, and positive infinity is way over there. Negative infinity to what? To 1? I think it goes past 1. 2? Yeah. Do I need a parenthesis or a bracket?
Parentheses.
Oh, parenthesis. Good call. Yeah, we can't touch the asymptote. Union what? 2, comma, infinity. Okay. Can't wait to see Toy Story 4. Haven't seen it yet. Nope. It's going to be a good red box. Don't spoil it for me. Okay?
Don't spoil our bad grade.
Okay. Describe its behavior. Okay, so we are being told to write limits for this. How many limits do you need for a discontinuity? We need 3, thank you very much. Can you describe them for me? That would be end behavior. We're not talking about end behavior. We're talking about the discontinuity at x equals 2. We need 3 limits. Can you describe them for me? What do you think? From the left. From the right. And the overall limit. Remember that? Okay, so it's a chance to redeem yourself from when we did this before. So we had to have 3 limits. The limit as x approaches to, how do we say from the left? Here, I need to zoom in. How do we say from the left? We use that little exponent, which looked like a minus sign, right? Just for abbreviatedness, we'll just use f of x. And we'll need to fill that in, and then we'll need to do the from the right version, limit as x approaches to from the right of f of x, which some of you are getting much better at writing your limits because you did a good job on the test when you wrote your end behavior limits. So I was happy about that. So what do you think? As you approach 2 from the left, you got to look at your picture. If you don't look at your picture, you won't know. As you're going to 2 from the left, what's happening? Ooh, negative infinity, yep. What's happening as you approach 2 from the right? Positive infinity. So what's the overall limit? Doesn't exist. Nice trip down memory lane. Now, I've added extra things in this. I graphed it. You need to be able to graph these. Okay? I know it just asked me to write down the domain and limits for those values not in the domain, but you need to understand what a discontinuity is, an infinite discontinuity like this. Vertical asymptotes, horizontal asymptotes. That's why I looked back and I said, hey, wait a sec, 1 through 22, let's cut out some of these questions because they got a lot of stuff to be able to do. That's why I changed it and made some of them just odds. Okay, let's see if we can get through these. No, that's not what I wanted. Maybe we need fireproof form. Now, second period asked me to remind them what fireproof form looks like for a hyperbola. Do you need me to do that for you? I mean, this is really generic. Y minus k over b equals 1 over x minus h over a. Okay, that's the most generic looking fireproof or standardization theorem form of that. This is almost in that form. You got to do one thing to put it in that form. What is it? Something to do with this. Yes, divide it. Okay, so by doing that division right there, we change it into, why isn't it? Oh, that's the wrong eraser. I need this eraser. So we have y over 2 equals 1 over x plus 3. Okay, so describe to me what's going on here. What's that thing doing to it? Vertical stretch. And what's this doing? Which way? It's either left or right. It is left 3. Okay.
So why is this fireproof form, like the x side being divided by 1?
Why is the x side being divided by 1?
I don't remember.
Okay, I think I understand what you're getting at. Every single fireproof form is based upon the original parent function. So like if you asked me for, y equals x squared, so you see what we're getting at? We started out with 1 over x. So that's you're basically starting with the reciprocal function. Hey, thanks so much. Yeah, you can just send him over there. That'd be great. He won't eat them. Okay, so what's going on with this graph? Left 3, stretch 2. Can you tell me anything about this graph? I mean, right down here, this should be screaming something at you. What? What is that x plus 3 doing? What's over here at x equals negative 3? Ah, the vertical asymptote. Remember, every single factor in the denominator is causing a vertical asymptote. Okay, well, what about the horizontal asymptote? Largest power of x in the top, largest power of x in the bottom. Try to squeeze this in here. The limit as x goes to infinity of 2 over x What happens as x gets larger and larger and larger and larger and larger and larger and larger? What is 2 divided by a really big number?
A very, very small number.
Yeah, what's it getting close to? 0. So there's your horizontal. Right? Y equals 0 is your horizontal asymptote. Makes sense, folks, because there was no vertical shift. If I were you and I'm trying to figure out the branches, I might plug in 2 and 4. Actually, sorry, -2 and -4. Well, give me my negative. There we go. -2 and -4. So if I plug in -2, what do I get? Plugging in -2 right there. +2, don't you? 2 over 1. So at -2, we're talking about something up here. Right? Because -2, +2 brought me up above that horizontal asymptote. So what will -4 do? That gives me a -2. 2 over -1. So we're down here, which puts that branch doing this. They said, describe how the graph of the given function can be obtained by transforming the graph of the original reciprocal function. All right, we already did that. We said vertical stretch by 2. We shifted it left 3. Identify the horizontal and vertical asymptotes. Already did that. Use limits to describe the corresponding behavior. Okay? For sake of time, I'm not going to do the limit part. You know there's going to be 3 limits for that point, that discontinuity. It's pretty much just like the last one. I really want to get to this other one in B and show you something for question 3. Any vertical asymptotes? Two. Thank you very much. You looked at the denominator. You found your vertical asymptote. Largest power of x in the top. Largest power of x in the bottom. Take the limit as x goes to infinity of that thing. And the answer is 3. Thank you very much. Notice how that was pretty nice, right? The x is canceled. So guess what? You found your horizontal asymptote. We already know the vertical was here from that. So 1, 2, 3. We've got my vertical asymptote up here. Okay. I suggest you plug in a 3 and a 1. Those aren't magical numbers, folks. I'm just going 1 unit on either side of that vertical asymptote. If you like other numbers, like you want to plug in 0 on the left, that's fine. There's nothing wrong with that. Pick what you want. So what do you get? 3 times 3 minus 7 over 3 minus 2. What'd you get? 2. So at 3, we're at 2. That puts me, folks, that puts me below the horizontal asymptote. All right, so 3 times 1 minus 7 over 1 minus 2. Did I do that right? 3 times 1 minus 7 over 1 minus 2. Okay. What did you get? Is that tricky? 3 minus 7 all over negative 1. What do you got? Positive 4, thank you very much. So we know that this branch is up here. I really need you to look at the factors in the denominator to find the vertical asymptotes, and to look at the largest power of x in the top and the largest power of x in the bottom. Take the limit as x goes to infinity, and that will give you your horizontal asymptote. Then you can look at the graph, plugging in values just to give yourself a little bit of a start. Now, I don't know if I included the numbers at the end of this, so if I didn't, I'll have to jump over, and I don't think I did. Okay. Well, possibly I might be able... Nah, let's just jump over to the one that I'm thinking of. Nope, that ain't it. Don't. Why is it moving away from me? Is it because it's... Oh yeah, there we go. That's why. So the one I'm thinking of is question 3. And that is not going to be big enough, maybe. Oh no, that's as good as it gets. So it's hard for you to see this, so I'll write it larger. Negative 1 over x squared minus 4. What I really would want you to do with that question is to focus your attention down here. What are you going to do with that? What do you think the first thing you should do with that denominator is? Not this. Factor it. Thank you so much.
End of the day announcement that concerns tomorrow morning. Please remember, many of you were spoken to first period by your teachers concerning the ASVAB test tomorrow. We'll have many students first period reporting to a couple different testing areas. Make sure that you are diligent in being there at the beginning of the day. If you have questions in the morning, there will be a number of people.
I should pause this. I really don't want to hear this.
Most of the testing will be in room 303, the cafeteria, in the community room. So ASVAB testing tomorrow. It does not include everybody.
Come
Most
on.
of you who are part of that already.
I'm busy here.
Are.
Thank you. All right, now, factor it so that you can see what? What do you see now? How many vertical asymptotes? 2. You've got one over here and one over here. Now, what you're going to have to do is plug in numbers to see what happens on the left side, on the right side, but what's going on in the middle is probably more interesting. So pick 0, plug it in. What do you get when you plug in a 0? Tell me what you get when you plug in a 0. Come on, negative 1 over negative 4. What do you get? 1/4. That means this part in the middle. Now, if you did this, and I'm running out of time here, when you plug in values, what you're going to find is the section in the middle has what almost looks like a parabola, but it can't be a parabola because it can't go past those vertical asymptotes. And then there'll be 2 other branches, and if memory serves me correctly, they'll be like this. Yes, I can. Hold on, I'll clear this off. And close this. Come on. Block that. Close that. Nope. And jump back here. Yes, oh, I definitely will. Yep. The part on the right you want to look at? Sure.
So the vertical asymptote is
X equals 2. That's from your denominator factor. And the horizontal asymptote comes from the largest power of x in the top divided by the largest power of x in the bottom, and you take the limit as x goes to infinity of that, which, as you know, most of you said was y equals 3. Got it? Okay. Yep. So when I looked at this, I saw 3x was the largest power of x in the top, and we had 1x, which is the largest power of x in the bottom. For that last example I did, that was in like number 3 in the homework, we had a -1 on the top and we had x squared on the bottom. So I would be taking the limit as x goes to infinity of -1 over x squared. They won't be super duper challenging. We'll try to make them a little bit nicer.